Hello, future engineers, subscribers, viewers, and students. There is a video on limits, and I consider them beautiful. Although there are techniques on how to solve this in order to obtain the answers correctly, you have to use the calculator. But I'll present this in a manner that is logical uh, so that your skills in algebra, trigonometry will be enhanced. And these are the problems to be presented on the next slide. So here are the problems to this part. Evaluate the limits if they exist. So in this slide, I will present the solution to the first three. Then the last two will be on the next slide. So first, if we're going to analyze part A, we're going to rationalize the numerator first so that it will be free of radicals, and to anticipate, after we multiply the numerator and the denominator by the conjugate of the numerator, this will be cube root of x minus 2, which is a factor of x minus 8 if we're going to force it, leaving cube root of x minus 2 cancelable when x approaches 8. So that's the idea until such time that we can get rid of the indeterminate form 0 over 0, because this is 0 over 0 if we try to evaluate the numerator and the denominator. So as I said, the technique will be left to you. Use your calculator if you want, but I'll present the traditional way of solving this problem so that students who are still planning to take up engineering and mathematics will be able to enhance their skills. So first, let's multiply everything by the conjugate of the denominator, which is square root of quantity 7 plus cube root of x plus 3, and divide the same thing. So this is difference and sum, so it's the square of the first minus square of the second. So this is now equal to limit of 7 plus cube root of x minus 9 over quantity x minus 8 times this quantity square root of 7 plus cube root of x plus 3, which reduces to cube root of x minus 2 over cube root of x minus 2. Let's factor cube x minus 8 and write this as cube root of x quantity cube minus 2 cube. We have difference of 2 cubes. Factors are cube root of x minus 2, then square of the first, remember, plus twice the product, so 2 cube root of x, and square of the second, which is 4. And we just copy this part. So we can cancel cube root of x minus 2 because x approaches 8 does not mean x is exactly equal to 8. So this reduces to 1. So we have limit of 1 over cube root of 8 square. We now substitute x equals 8 because this is no longer approaching 0, the denominator. So cube root of 8 square plus 2 cube root of 8 plus 4 times quantity square root of 7 plus cube root of 8 plus 3. This is 4. Cube root of 64 is 4. 2 cube root of 8 is 2 times 2, so another 4. Then plus 4, that's 12. Square root of 7 plus 2 is square root of 9, which is 3 plus 3 is 6. So that is 1 over 12 times 6. So that would be 1 over 72. So that's the answer to the first problem. For the second one, we have limit of quantity x minus pi over 2 over quantity 1 minus sine x as x approaches pi over 2. Another indeterminate form because the numerator approaches 0, 0 square. The denominator, when x approaches pi over 2, 1 minus sine of pi over 2, this approaches 1, so 0 over 0. So let us denote this whole quantity x minus pi over 2 as theta. And take note that when x approaches pi over 2, theta approaches 0. So we change the variable to theta, and theta approaches 0. Then x is theta plus pi over 2 from this equation. So limit as theta approaches 0 of theta square over 1 minus sine of quantity theta plus pi over 2. We then expand this into limit as theta approaches 0 of 1 minus quantity sine theta cosine pi over 2 plus cosine theta sine of pi over 2. And we note that cosine pi over 2 is 0 and sine of pi over 2 is 1. So that the denominator is 1 minus cosine of theta because this is 0. We then use the identity for 1 minus cosine theta, which is 2 sine square of theta over 2. So we have 2 sine square of theta over 2. Then if we make this theta over 2 quantity square, then we should multiply the numerator by 4. So limit as theta approaches 0 of 4 times quantity theta over 2 square over 2 sine square of theta over 2. 4 over 2 is 2, and actually limit of theta over 2 over sine of theta over 2 quantity square is 1. I'll just transform it or arrange it into sine of theta over 2 over theta over 2, then quantity square, because that's the formula where the limit is equal to 1. So this is equal to 2, limit as theta approaches 0 of 2 over sine of theta over 2 over theta over 2 quantity square. We bring this down as denominator, then that's squared. So since this is equal to 1, the limit of this ratio is 1. So 2 over 1 square is still 2. So therefore the limit is 2. Then for part C, we do the same thing. We make pi over 2 minus x as theta. So limit of pi over 2 minus x over cosine of x. So we denote theta equals pi over 2 minus x. And we note that when x approaches pi over 2 minus pi over 2 approaches 0. But not exactly pi over 2, of course, close to pi over 2. So theta approaches 0. And we replace x by pi over 2 minus theta. So that's the complement of theta. So that cosine of quantity pi over 2 minus theta, so it's like cosine of complement of theta, which is sine of theta. So limit as theta approaches 0 of theta over sine theta, again rearranging this into limit as theta approaches 0 of 1 over quantity sine theta over theta. And we know that sine limit of sine theta over sine theta is 1. So that is 1 over 1, so 1. So for this last part, let's have parts D and E. So for part D, we have to multiply the numerator by -1 as well as the denominator to transform it into uh, negative sine of 4x. So limit of negative sine of 4x over quantity 1 minus cosine 3x. And then we use the identity for 1 minus cosine 3x, which is 2 sine square of 3 halves of x. So take note that for this problem, x approaches 0 from the left. So for calculator techniques, you can only assign negative 0.00001. So negative 0.0001 and not 0.00, positive 0.0001. If you want to use your calculator, but as I said, I'll present the solution. For this numerator here, I'll multiply 4x and divide sine 4x by also 4x. The denominator sine square 3 halves x, I will multiply by 3 halves of x squared. So I also divide 3x over 2 quantity squared. So that's it. Limit as x approaches 0 from the left is negative of 4x because there's a negative sign there over 4x. That makes it 1 over, so as I said, I divide the denominator by 3x over 2 quantity square. So I also multiply it here, 3x over 2 quantity square. So we have um, that is equal to negative, because this is 9x squared over 4, then times 2, 9x squared over 2. Then this 2 here will be shifted to the numerator. So that will be negative 8. Then we cancel x because the denominator is x squared over 9. So negative 8 over 9 x. Negative 8 over 9 sine of 4x over x, then divided by x times quantity sine of 3x over 2 over 3x over 2 quantity squared. Finally, take note that the limit of this is 1 as well as this is 1. So that reduces to limit of negative 8 over 9x as x approaches 0 from the left. Since 0 from the left, like negative 0.00001, negative over very um, negative 8 over 9 divided by negative 0.00001, which is very, very small. This gives us positive infinity. So the limit is positive infinity for that case. Then finally, part E, we have limit of quantity 4th of quantity x to the 4th plus 1 minus square root of quantity x4 plus 1 over x squared. So again, you can use your calculator in verifying answer. That's the technique. Or you can use L'Hopital's rule. You differentiate independently the numerator and the denominator until such time that it will not be of the form 0 over 0. Like in this case here, we have 0 over 0 in this case. So the technique here is we have to do something to make it, we can evaluate this. So let's make this 4th root of x to the 4th plus 1, then minus 1 all over x squared, then plus quantity 1 minus square root of x squared plus 1 all over x squared, then combine. So I introduce negative 1 over x squared here. I also introduce 1 over x squared to the right, so that maintains the original function. Then after that, I'm going to, let's rationalize the numerator here. This is 4th root of quantity x to the 4th plus 1 minus 1. So we multiply and divide by 4th root of quantity x to the 4th plus 1, then plus 1, and divide the same thing. Then likewise, for the other part, let's just leave it at is first, although we can do it at the same time by multiplying the conjugate of the numerator, which is 1 plus square root of x squared plus 1, then divide by the same thing, 1 plus square root of x squared plus 1. So let's just focus on the first term first. We multiply and divide by 4th root of quantity x to the 4th plus 1, then over 4th root of quantity x to the 4th plus 1, then plus 1. Then for the second term, we just leave it at is first. So this is now square root of quantity x to the 4th plus 1 minus 1 over x squared times quantity. We copy that. And also for the second term, we just copy it first. So next, we rationalize further. So we rationalize the numerator of the second term by multiplying 1 plus square root of x squared plus 1, the conjugate of this, over the same thing. We also rationalize this further into by multiplying square root of x to the fourth plus 1, then divide the same thing. So we copy everything, then multiply and divide by square root of x to the fourth plus 1, then plus 1 over square root of quantity x to the fourth plus 1, then plus 1. Then this one becomes 1 minus x squared minus 1. Limit as x approaches 0. So this reduces to negative x squared over x squared, which is negative 1 over this remaining terms in the parentheses. This first term reduces further to square root of x to the fourth plus 1 minus 1 over, we copy the whole denominator. I will not just mention that. And this becomes negative 1 after we cancel x squared. We can cancel x squared. And take note, the numerator is just negative x squared over x squared. So negative 1 over quantity 1 plus square root of x squared plus 1 plus 1. Which is when x approaches 0, negative 1 over 1 plus square root of 1, which is also 1. So this is negative 1 half. And as x approaches 0, because the numerator is x to the fourth, denominator is x squared, we can cancel x to the fourth and x squared. So x squared left in the numerator. The denominator will consist of these two quantities in the parentheses. And we note that the limit of the first term is, we have nothing to do except that this is 0. So we can substitute now x is 0. And this one is negative 1 half. So finally, because the limit of the first term is 0, as x approaches 0, final answer for that limit is, the final answer for the limit is negative 1 half. So that's it for this video. I hope that you also find it beautiful. And there are problems on limits where you can also evaluate in this manner, of course.